students and families. Thank you for tuning in. Welcome to Week 8, Lesson 1 for the week of May 4th through the 8th. This video is to support schools using the Bridges Math program. My name is Miss Greenwood, and we're going to have a blast figuring out the mystery of solving two-step word problems. Materials that can support today's learning include pencils and scrap paper. Let's get started. Objective. Students will solve two-step word problems involving all four operations, but using properties of operations and visual models in order to solve real-world problems. When we talk about operations, that is defined as any procedure such as addition, subtraction, multiplication, and division, in which numbers are acted upon according to a set of rules. As we figure out the actions and gist of story problems, we will come up with a sequence of two steps to follow that will help us to answer the question being asked from our word problems. It's going to involve some detective work, but together we will face these story problems and apply strategies to help us persevere. Think about it. What patterns do you see? What do you notice? The first image has one pen. Now there are 3 pens. The number of pens has increased. What do you wonder? I wonder how many pens will be in the next picture. Turn and talk or turn and jot. What patterns do you see? How many pens do you think will be in the next picture? We will come back to discuss shortly. In our first picture, there is 1 pen. In our second picture, there are 3 pens. In our third picture, we now see 7 pens. Our pattern continues. Math detectives notice patterns and wonder how the patterns grow. When we look for patterns, we are thinking about how the pictures are different from one to the next. That helps us think about what could come next in the sequence. If this pattern were to continue, what would the next 2 pictures in the sequence look like? Now that you're on the case, be sure to share your thinking with others. Learn about it. For our first read of this story problem, we are going to think about what is this situation about. One way to help us think about story problems is to visualize and then create a quick sketch or drawing with enough detail to retell the gist of the situation. To help us focus in on the actions of the story problem, I'm going to go ahead and block out the numbers or quantities in the problem. Let's read. Jake found shells on the beach. He gave some to his brother. Then his sister gave Jake more shells. Did you visualize what was happening in this situation? How did you sketch the action of the story problem? Here's an example. So we have a boy named Jake, and he found shells on the beach. He decided to give some to his brother. Then later, his sister decided to give Jake some shells. This is what happened in the story problem. For our second read of the story problem, we will focus in on what are the quantities or numbers involved in the situation. Let's read. Jake found 32 shells on the beach. He gave half of them to his brother. When you give half of your shells to your brother, you could be subtracting, or because there's 2 equal groups of the 32 shells, we could be dividing. Then his sister gave Jake 18 more shells. His sister's giving him more shells, and that makes me think that we would be adding to what he has left after giving some to his brother. Let's create a visual model to represent the actions and quantities involved in this story problem. So we know Jake starts with 32 shells. And we know that these 32 shells we can think of in 2 equal groups because he's going to give half of them to his brother. So at this point, Jake's going to have less than 32 shells. He'll have actually half of his 32 shells left. We find out that his sister will give Jake 18 more shells. So he's going to have his half that's left over plus 18 more. For our third read of the story problem, we will focus in on what mathematical questions can we ask about the situation. Let's read. Jake found 32 shells on the beach. He gave half of them to his brother, then his sister gave Jake 18 more shells. We could ask, how many shells did Jake have left after giving half to his brother? We could also consider whether Jake had more than 32 shells after his sister gave him 18 more. This particular story problem has a specific question for us to answer. How many shells does Jake have now? We will create an answer statement to address this question. Jake has blank shells now. Look at the following equations being shown. One of them represents the action of the story problem. When we look back, we know that Jake started with 32 shells. The first action in the story problem involved him giving half to his brother. When we give half of the shells to the brother, we are removing a portion. There will be less than 32 shells. So this does not seem to match the multiplying by 2 in parentheses in either the left equation or the equation in the middle. However, when we think about giving half of the shells to the brother, we can think of 32 shells being split into 2 equal groups. This would match 32 being divided by 2. We know the second action in the story problem involves his sister giving Jake 18 more shells. This is represented with the plus 18. Let's go ahead and consider that the question mark being shown to the right of the equal sign involves answering the question, how many shells does Jake have now? We will go ahead and complete these steps to find out what that amount is. We will start with 32 divided by 2 in parentheses. 32 divided by 2 will give us a quotient of 16. We will now take 16 and add our 18 to represent the 18 additional shells Jake got from his sister. When we add 16 plus 18, we can think of it as a 10 and a 10 being added together, which gives us 20, and then adding our 6 ones and 8 ones for 14 ones. And altogether, that would give us a sum of 34 ones. So we now know that Jake has 34 shells. For our first read of our next story problem, we will think about what the situation is about. As we read, let's visualize and create a quick sketch to retell the gist of the situation. We will block off any quantities or numbers so that we can focus on the action of the story problem. Let's read. Ebony and her sister Tanya are making bracelets at home. So far, Ebony has made some bracelets with some beads on each one. Tanya has made some bracelets with some beads on each one. So I'm visualizing a pair of sisters, Ebony and Tanya, and they are making bracelets with beads on them. That is what this situation is about. For our second read of the story problem, we will focus in on the quantities involved in the situation. Let's read. Ebony and her sister Tanya are making bracelets at home. So far, Ebony has made 3 bracelets with 11 beads on each one. Tanya has made 2 bracelets with 12 beads on each one. Let's use a visual model to represent these quantities. I will use base 10 or number pieces to help me represent these quantities. Let's start with Ebony. Ebony made 3 bracelets with 11 beads on each one. I can think of this as 3 groups of 11. I can make 11 using a 10 and a 1. So now I have 3 groups of 11 being represented by the base 10 pieces. Let's focus on Tanya. Tanya made 2 bracelets with 12 beads on each. I can think of 12 beads as a 10 with 2 ones. And because she made 2 bracelets, I will need 2 groups of 12. For our third read of the story problem, let's focus on the mathematical questions that we can ask about the situation. Let's read. Ebony and her sister Tanya are making bracelets at home. So far, Ebony has made 3 bracelets with 11 beads on each one. Tanya has made 2 bracelets with 12 beads on each one. Some mathematical questions that we could ask could involve finding out how many bracelets were made. We could also find out who made more bracelets than the other. We could also focus in on the number of beads it took to make the group of bracelets for each sister. This story problem does have a specific mathematical question for us to answer. How many beads have they used so far? Because we're being asked how many beads they have used so far, this means we need to figure out how many beads Ebony used to make her 3 bracelets, and we need to find out how many beads Tanya used to make her 2 bracelets. And then we have to combine those totals to get a total number of beads they both used so far. Let's create our answer statement. They used blank beads. To represent how many beads, which is what we are looking for, we will use the letter B. B equals beads used. To set up our equation, we will need to think about how Ebony made 3 bracelets with 11 beads on each. This is 3 groups of 11, which could be represented by 3 times 11. Tanya also made 2 bracelets with 12 beads on each. So we can think of Tanya's beads as 2 groups of 12 or 2 times 12. The quantity 3 times 11 plus the quantity 2 times 12 will equal B, the number of beads they both used. Let's go ahead and solve to find these products. When we think about 3 times 11, we can think of the 11 in friendlier numbers, like 10 plus 1. Multiplying 3 times 10 and then 3 times 1 could help us find that product more efficiently. 3 times 11, or 3 times the quantity 10 plus 1, will give us a product of 33. 2 times 12 can be thought of as 2 times the quantity 10 plus 2. 2 times 12 gives us a product of 24. We now need to add these 2 products together to find the total number of beads used. 33 plus 24 gives us our final answer of 57. So our answer statement is they used 57 beads. Now it's your turn to try it. Complete page 122 using the examples from today's video. Consider applying strategies we practiced, including 3 reads, visualizing, drawing a quick sketch, and creating visual models. As you complete these practice problems, pick the equation that will help you solve the problem. Then solve the problem and show your thinking. Until next time, third grade math detectives, take care, stay safe, and stay connected.